Ahmed, thank you very much for joining us here on AU Manufacturing Conversations. It's a pleasure to have you on the program.
Oh, thank you. Thank you. My pleasure. Anytime.
First question, as always, is how did you get here and what do you make?
We're a group of roboticists, and we sort of use robotics in automating other industries, applications, if you will, for other industries. We got here by putting together a very smart business plan. Folks sometimes forget that engineers also know a thing or two about economics, and we're trained by nature to solve problems. We felt that there was a problem in the construction industry, and it's a problem as simple as why would they not using these tools? Well, some folks have tried it overseas, but we realize also many of those whom are trying into bringing automation, they're not necessarily specialized in robotics or took this problem seriously. For one reason or another, there was an acquiescence among all stakeholders that, it's not the most efficient way to construct. And I'm not talking only about residential or commercial, but even civil infrastructure. But then no one wanted to change anything. Like there are these ideas, concepts here and there. And we started by building the first mobile gantry or mobile robotic 3D printer in the Southern Hemisphere. Mm-hmm. It was a small one. Most of our backgrounds in academia, so you start with a small prototype, you test what it's capable of, and then the materials, because a big part of this is materials engineering. And we were lucky to have that sort of training where you could figure out the issue and then put very logical steps to resolve them and bring it to a commercial product. After that, we were overwhelmed with the response from the market, the enthusiasm that you get from the everyday person, from the moms and dads, how everyone was frustrated. And sometimes I would say pissed off because there's technology like these and somehow we're still stuck in old ways. And this is a problem across the globe. People have a problem with construction, with having a house. That's the beginning.
And so you mentioned that before we started this conversation and recording, you mentioned that you were a robotics researcher. Are you all sort of in robotics type fields?
Well, most of us studied mechatronics, which like for our undergrad degrees, and that's kind of the place where you start your relationship with robots.
Yeah.
Or you start your love affair with robots.
Gateway drug.
Yeah, exactly. And from there, we were doing postgrad studies and we were teaching, tutoring. So we're teaching the robotics. Sometimes the tutor do more than in terms of talking about there is that enthusiasm and fervor when you're at that level and you're as an early career researcher. And there are these solutions here and there and the possibilities out there. So you will be well informed, if you will. That's where we were. And more importantly, it's talking, what led us to this is we were talking about something everyone in our age group talks about, but it's all complaining, no solutions. This is the most significant purchase in anyone's life. To own a house, for example, that's when it's for us. For the general public, infrastructure. These are also the most significant purchases or developments a state or a government could take on. These are the things that leaves legacies. So, and we saw that no one, for some reason, really cares about automating that sector.
Right. I can only think of one other Australian company, Fast Brick Robotics, who you're probably aware of. But other than that, not so much.
Like Fast Brick Robotics or FBR, they were actually, I would say, one of those companies that kind of pioneered in this. They're from out of Western Australia. And you bet we watched their videos a lot and we were happy with what they were doing. But they were like a kind of a single fighter there,
Right. So you mentioned some of the things that you've...
They inspired us, I'd say.
Good. Well, you've got to have inspirations. Tell me, please, about some of the things you've developed so far. You're making 3D printed houses, and there are a lot of problems to chip away at on the way to delivering that. As I see it, and I might be wrong, you've developed specialized concrete in-house, you've developed a robot, a specialized extruder that doesn't clog. Tell me about that and anything other than that that's worth mentioning in terms of this conversation and how far you've come so far.
Yeah, absolutely. So we developed a series of robots. We call them the platypus, and that's a reflection on our company and modern Australia. We are from many different parts that is unlikely to happen anywhere else. And we decided to solve also a problem on our own and take all the risks. And we use ultrasonics, which the platypus use. So in reality, and their duck bell. So the first printer was we called it the platypus. And then that is a printer that is very famous now among academics, whether they are in the States or in Queensland or New South Wales. Universities have bought into this printer a lot because it's, if you will, a lab-based printer. It's a robotic gantry. And then we came up with something called the Platypus Expeditionary, which is a mobile version of the first printer.
Yep.
And then we came up with a printer we call the X2, which is more for factory settings, for folks who want to do small prints or to print in a bespoke manner. And we've been developing the Platypus X12, which is a large-scale printer that can telescopically transform and change its size to make it more feasible for the logistics of construction actually cost a lot. That's what many folks forget when they make a very huge gantry that will cost you a lot just to keep it in a warehouse. So we kind of brought some ingenuity into making a very practical solution. Meanwhile, we were working on something we call Ultimatecrete, which is an eco-friendly cementitious mixture. And by eco-friendly, we mean like we reduce the amount of cement that you would need to make concrete behave in that way. And it is licensed now in a number of countries around the globe. And then to show folks how this works, we built the first ever 3D printed house in Australia and the Southern Hemisphere with the codes to show the code compliance. So we brought the building code. This is for residential. And as per the code, from how you tie the wall to the slab all the way to roofs, etc. And actually we surpassed the code 4 times, I'd say, and some of the metrics. Then we built another replica, and we started after that to take on serious construction projects like full developments. Although we're a robotics company, we're not really a building company, but we realized the need and the market opportunity is just too big to ignore. And so we are a robotics company that makes the robots here in Australia. The materials also have been concocted here, engineered, designed here, and managed to license it overseas and to sell our robots as well. So that's what we do, and we tend to invite people to come and see what a 3D printed house would look like. And last year, we realized that we solve a huge problem, especially for bulk builders. They are now the fastest, like residential bulk builders. Mm-hmm. They're the fastest growing adopters of this technology, and actually they're competing amongst themselves to get this technology on board for a simple reason. It gives the consumer that choice to change the outlay or the design of their house, which gives them that individuality. But also it really serves big time to get them out of this quagmire of a very unstable supply chains, which is unnecessary to build a house, really. It's just the methods. So when you change these methods, you have a more resilient supply chain because you reduce the requirements just to build a wall. And therefore, you can be more confident when you give people fixed contracts. You sign fixed contracts because you can control at least 80% of the cost that goes into a house.
You've mentioned some drivers there. Are they sort of common throughout the world, I imagine, or the developed world at least? And can you speak to me, please, about what's happening globally with 3D printing for construction? What are you noticing abroad and what are you learning from and, I guess, comparing notes with?
Well, the biggest world market, the biggest adopter are the United States. We see the number of companies growing there, buying printers. And actually, we've got more sales there than here in Australia in the first year. It just shows you, like, they were people there are just looking to solve this problem. The issue of materials, and then the numbers of human beings are increasing. By 2030, there will be 10 billion people. We're going to need houses. And the current way and method, I think it was the pandemic that kind of exacerbated this issue. Because I think the construction industry, they realized that they're depending on so many different or unnecessary methods or ways and means to build. And the skills are stagnated there in the sector where people don't know how to do this differently. Oh, there are no materials. That's it. Your house is not going to be finished. In Europe, we see some adaptation. We have a lot of competitors there. But I can tell you with high confidence in here that we at Luyten, we believe we're at the pinnacle of this game internationally. And we've competed with our counterparts in Europe, and we know we've won, let's say, 7 times out of 10. But we're still at the infancy of this game. And again, around the world, construction is still done like how it used to be done 2,000 years ago or 4,000 years ago. Except it became more complex because let's go 400 years ago. If you're getting married, let's say, or you come to a new town, you and your friends can just bring some buckets of mud, make some bricks out of it, and build a house.
Yep.
It's not even a thing. Having a shelter and a house is a human right. Nowadays, it's an economic instrument. And it's an economic instrument everywhere, by the way. Whether it's a developed country, not very developed country, you'll be surprised to hear about the prices of houses in some of the poorest countries in the world. It doesn't make sense. But that's the driver because it's a very secure asset. And we believe with technologies as such, the adaptation normally is for supply of new houses. And to make that so that is affordable, to at least match how it used to be easy 10 years ago, 20 years ago for folks who work, certain amount of years that you'll be able to pay for your house, or your house would cost 3, 4, 5 times your annual salary. Now that number has exploded everywhere, and not just in Australia. I'm talking even in Southeast Asia, Middle East. It just became unaffordable for young folks to have a house, and that means there is pressure on because there's no new supply. Supply is not fast enough. That means rent also go up. So it's a vicious cycle. So we believe what we can provide here is to give these folks who are the first home buyers an opportunity to get more affordable, to make it also more feasible, especially for bulk builders, to make it for them more feasible economically, and also give them that ability to produce more houses faster. It's just like any kind of food industry or a candy factory. You can bring 100 workers in the factory, do things manually. You'll make some profit, but your margins will be extremely thin. You automate most of the processes that doesn't need to be super complex, and then you make some more money and you end up producing more. Then the overall cost for the end user drops significantly.
You mentioned earlier that you'd had some enthusiastic adoption of your technology in the US. Can you say anything about sales abroad and how you've done there and how you've sold here? I'd be keen to know how many perhaps robots you've sold, if you're able to say.
We've sold more than what we, expected we would sell, So basically we sold out for this year until May. So We're still delivering some of those. In the USA, it's mostly construction companies, residential construction companies. And also we've licensed our materials for certain companies that already, some of them have bought our printers, but they use other systems. So they can use our ink. Our ink has been recognized to be very robust. But more importantly, and that's special about Luyten, that we understand economics. We understand that it's not just about the new technology and all the glamour, the glitter that come around it. No, it's already about, if you will, the food chain in this industry. How to make everyone first get a better product. You have a house, when you 3D print a house that has a compressive strength at 82.5 megapascals that can withstand a mortar shell and an earthquake. Cheaper, but also better quality. So it's good for the builder, good for the developers, because they know these projects that they take on, it's not gonna drag, or we're talking about mud that you use for roads, you use for bridges. There is a plenty of supply of that. So whatever happens overseas is highly unlikely to affect you. At the same time, you deliver the house or the project for the person faster. Get them off that trend. Get them off that anxiety that comes with waiting. Yeah, I'm developing a house. Everyone knows that this is a story that either could go so well or could be a nightmare. You give people more certainty. And so that's the adaptation. Yes, it's taking place in all these places. In some countries, because of how the materials we use can withstand better against the natural elements. At the same time, in Australia, yes, adaptation is very well. But how do we say? We're overwhelmed at this stage. So scaling up, I can tell you that much.
Okay, well, you're not allowed or not willing to say how many units you've sold, and that's fine, but can you tell me if you're taking on people and the size of your team at this point due to the higher than expected demand?
Yeah, actually, then it's a good opportunity to tell the listeners that we're hiring. So if anyone sees himself fit to join Luyten in its mission, we are hiring, actually. I'm not sure if you're aware, but it's been a struggle to hire people lately. I don't know why, but we are hiring. So for folks who look to join a very innovative company that looks to change the landscape of how human beings build dwellings for the next millennia or so, please send your CV or resume to info@luyten3d.com.
And what roles are you looking for?
Many technical roles, obviously. As you have more teams to go out to the sites to print. So obviously you need more folks who have that mechanical aptitude as well as administrative, etc.
You mentioned some of the obstacles, I guess, to do with what you're doing. What can you say further than that about the challenges overall in building a printer that does what you want it to do, printing in concrete? Are they mechatronic problems or software problems or structural engineering problems or chemical problems? What are some of the things that have given you the most headaches?
Well, all of those have been done well. We're good in Australia if you want to build a machine because we have a lot of steel around here. You can get some very good materials to build a machine. The same with materials. We have a lot of natural resources and natural materials that this is what gave us an edge. Okay. Whatever kind of derivative of, certain industrial waste, we can get it for free even. So it's not that. The biggest problem, I think, as an Australian industry is we realize we're really weak in electronics in Australia. We have a serious problem with electronics. Right now, to make your own chips or printed circuit boards, etc., that's a serious weakness. The wait times, it affects our wait times. And then sensors. I don't know why this is the case, but I think this is an area that should be looked at. There should be more investments in that, if you will, sector, the microelectronics and sensors, because you cannot depend on that. These are critical stuff. If you want to build anything that is high tech, obviously, and it can generate a lot of income. And I thought we were the only ones complaining, or we didn't know where to buy some of these things, but it was something across the board. And then the wait times for these things to come from overseas, or sometimes when a certain model is not produced anymore. So it affects the quality of, the consistency of your products using the same sensors or etc. Software-wise, or even electronic-wise, and this was surprising to me because we have a lot of good engineers here. But still, to send a job on this, we depend solely on international supply chains, which obviously is very dangerous, and hopefully we will see that change sometime soon, and more investments to localize. Especially, this is the age of the fourth industrial revolution. AI will be more ingrained in our societies, whether we like it or not. And having a lot of good sensors made here would make a lot of differences and reduce the costs eventually if you want to localize high-tech industries in Australia.
Yeah, I mean, it's a difficult problem. This probably is getting into the weeds some, but it's hard to know where to start. If I were tasked with solving this problem, how do we get more skills, more companies? Is it a demand problem? Is it a skills problem? Is it you build this factory with government money and nobody buys from it problem? It's very multifaceted, and thus it's a tough one to solve.
I would agree with that. Like, we've got some very, very skillful technicians who used to work in the automotive industry, and they used to use robots, make certain circuitry, etc. And I think there is it's almost, a sad story here where you see that their skills are not being transferred. They were just sitting doing other things that are unrelated. So I think some of the main industries here should have not been totally let go. And that's my opinion, because there are so many skills down the line, down the production line that you don't want to lose as a country. I guess almost it should be treated as a national priority kind of wealth thingy, that you have these kind of folks.
Agreed.
In your industry, yeah.
To some degree, I think it's healthiest to look forward and to think what we can be doing tomorrow versus what we lost yesterday. But at the same time, I have to agree that if you lose an industry like automotive, or if you don't have a huge presence of electronics, according to the International Federation of Robotics, those are the two places within manufacturing that generate the most demand for automation and for robotics adoption. So that explains why Australia is so weak in industrial robotics adoption. And I looked at their figures, and there was a big bump in the year 2011, I think, that had not since been replicated or anything like it happened. And I said, oh, what was that? And they said, oh, that was the year that Toyota was tooling up its factory. And so that's why all these robots came into the country at that time. So, yeah, I'm not sure how to draw a close to what I'm saying now, but I agree that if you don't have automotive in a country, you lose a lot else.
Yeah, I mean, I agree with you. We should look forward, but I was just giving you my personal analysis because we've managed to find folks who are very skillful to work for us. And they were kind of on the shelf for a while.
Yeah.
And that what you just described explains a lot. I think going forward, we cannot depend on supply chains from unstable places in the planet. And we should be just more self-sufficient and look forward to export more high-value products because they create all these kind of jobs, as we know. So I think that's one thing. Like, it's weird. It's weird for me. Like, there are things that I'm trying to figure out myself. But when you have the best engineers, you have the best things, we can really design some cool stuff. Why lose this? We should really cultivate what we've invested in, because this education is investment. And hopefully we will see this to change in the coming future. Yeah.
I live in hope, as we all do. Back to some of the houses you're building, can you say anything about if reinforcement is needed to make these structures suitable?
Theoretically, you don't really need to reinforce if you're using something as Ultimatecrete, but per the code of compliance, yeah, we use reinforcement. There are structural columns, and it's just according to the code. It's just according to the code, but let's say it's precision construction.
Okay. And another thing I wanted to ask about, if you can give an interesting answer, great. If you can't, then that's fine. As an engineer, you know that any interesting bit of technology is great, but standards are really, really, really important for adoption and widespread use of whatever it is and it making an impact. Tell me, please, about standards development for building using concrete 3D printing.
So, yeah, I can tell you, along with FBR or Fast Brick Robots, very great Australian company from Western Australia, Luyten and all the other 3D concrete printing companies worked with the ISO and the ASTM to put the first code standards for this technology in building. And the first draft was published late last year because there are so many experiences around there and people have already built houses with those. So it's about the quality control, structural soundness, etc. And in Australia, we've showcased, I think, the first ever house built here. We did it in 2021 in December, in the summer in Melbourne, which is not the best time to concrete, according to traditional concreters, but we made it in that time on purpose. And we showed we could be compliant to the code, but there was almost a consensus internationally among everyone who's doing or engaged with this technology to standardize it and to put together ways and means so that it can be adopted at large on the mainstream. And I think that first draft was something that we're all proud of. And there are efforts for us in Australia to adopt that as well.
And I wanted to ask about 3D printing. Obviously, it's changed the way designers and engineers think over the last 20 years, and design for manufacturing and design for additive manufacturing, and thinking, instead of how do I make something the old way, but with a 3D printer, you realize, I guess, that there are so many different ways that are vastly superior to design things and that are now possible versus subtractive manufacturing. Not in every case, but in a lot of cases. Do you see, as you mentioned earlier, you see this being the future of the next millennium, perhaps, of construction? Do you see a mindset shift happening as 3D printed houses are adopted and the industry that designs and manufactures them comes along with it?
I think that this is a great question, first of all. And I'll share with you a story as someone who designed machines myself and many of my colleagues. It used to cost to prototype something using subtractive machinery. Normally, we would try to avoid that because it costs so much. It used to cost to just make a prototype that wouldn't work. And I'll give you an example here with our precipice extruder, which, we filed a patent for it at the time. Because some parts of engineering, it's actually what we call phenomenological. You optimize it by trial and error, and then back calculate and relate it to the theory, if you will. For us to do one of those precipices, it would have costed us $5,000 if we wanted to do it, with all the iterations that we needed to. Let's say if we were to use the traditional way of engineering something and designing it. 3D printed helped us to make every prototype not cost more than $30. That's an example from our case, that we use 3D printing. There is a generation of engineers now. There is hardly anywhere in the world where an engineering department wouldn't have 3D printers, like plastics, all type of different materials. The best response we've got about 3D printing is from the architects, because they have been, for years, suffering that in their designs and their concepts, they have to deal with this statement: try to minimize curves. It costs more in the final project. And now we're telling them, okay, what you've been saying and hearing for 30 years, could you forget about that and give us more curves? We're having a conversation a couple of weeks ago, and he's a well-seasoned architect, and I said, okay, Ahmed, you want me to forget about 30 years of how we used to do this? You're asking for more curves. I was like, yeah, it will look beautiful here, we'll do that. Or we see architects are very vigilant. I can see they're watching, they've been following this technology. The thing is, we made their job easier. Whatever computer-aided draft that they made, we can make it into a 3D printable code. Bear in mind, geometric code or G code is not something new. The first geometric code was in the 1950s. It's just the way where we got, it's the amalgam of the advances in materials engineering, where we can make concrete behave in this manner. We kind of took advantage of developments in nanotechnology, for example, to make additives that can make and change the concrete at that level. So we're not concreting the same concrete they used to do in the 70s, 80s, 90s, or even now for public works. And it's cheap enough. I remember, there was a time when people said nanotechnology, nano this, nano that. Many didn't understand all these investments. Where did it go? Well, it went everywhere, down to your shampoo. Some shampoos use, but the price of it it's affordable to use it now.
For sure. I remember seeing an Australian company, Eden Concrete, making carbon nanotube reinforced cement, and that would years ago be just unheard of because it would be so incredibly expensive, but the cost of that has come down with the technology.
So now the technology is out there in abundance. You can actually make it cheaper than the traditional method. So the materials advancement allowed us to bring about robots, and also there are a lot of new actuators, new sensors out there that we could make the printer smart to realize when there's someone there and how not to hit him. How if, let's say, strong winds came or someone pushed it, it will compensate automatically for, it will know how the materials will behave. All of these things came to fruition. And yeah, that's what a mechatronics engineer, going again, the entry drug to all this addiction with robots, it comes from there. How to build a very complex system that is multidisciplinary. And if one of these sub-disciplines get an extra improvement, that makes the device work better. And therefore, right now, we know it's code compliant, it can be easy to use, and the geometric code or G code is not just something only subtractive manufacturing can use. No, actually, we can do it in the additive and also get it to extreme accuracies and get a good product. So I think these are some of the things people ought to understand. And this helps the architects who now I can get that done without having to get with crazy quotations. If I do it the normal rectangle wall or give it that beautiful feature that will give it these kind of properties and prolong its life cycle or whatever it is, that wouldn't cost him more. So that's why they are our biggest supporters thus far. But talking in general, we've also opened the door to other modern methods of construction. There are a lot of new products that will be easier now to use, whether it's a roofing product or how your whole electrical house grid. So there are new patterns in the industry. And I'll mention here one company, PT Blink, out of Sydney. So these are companies that actually are looking at the whole sector and how to bring manufacturing methods into the construction site so that there are not a lot of thinking in the site. It becomes a plug and play. They look at 3D printing and how that makes it easier for them to, sometimes you can fit whatever you have in your inventory to the thing. So the supply chain or the shortage of materials is not a shortage anymore because your carpenter cannot do the windows certain size. So there are all these things that were stifling that are now out of the way, that we can just change that simple, method of constructing a certain element in the house. The other thing is, look at it like the power battery drill. It creates more jobs. It's just safer now to operate a drill. I'm not sure, but I remember a time when if you wanted to operate a drill, you'd have a long wire and you had to be a specialist and it would sound really loud. But now we have all sorts of drills. So that's something that made it easier to do things back in your backyard. So it's a tool. What we're providing is a tool we believe can help with all those.
And so just a couple last things, because I've used up quite a bit of your afternoon. A standard question for this series is there an issue within manufacturing at the moment that you think isn't getting enough attention?
We need more folks, and this is for us in terms of manufacturing. We need more folks or more TAFE programs that deals with high-tech systems, such as mechatronics or robotics specialties. I believe that the supply of well-versed workforce would go a long way, and it's kind of a problem right now. Because you get engineers, but it's not all about the engineers. We need technicians as well. So there's a gap there, and that's how we feel.
So lastly, is there anything you'd like to plug or any final comment you'd like to make while you're on the line?
Yeah, buy Australian. We're at the pinnacle of this game. Thank you. It was my pleasure being with you.
Yeah, no, thank you very much for being on AU Manufacturing Conversations.
Yeah, you're welcome.